Good morning, and hope you all are having a good Wednesday. We are going to finish up Indicator 5 with the last bit of new material, and then tomorrow we will review, and Friday we will quiz for Indicator 5. And Indicator 5 is dealing with linear equations, and this slide is just a review of everything that we've talked about so far and what we're going to talk about today. So linear equations just simply means it graphs a straight line. And it can be in three different forms. That linear equation can be written in three different forms just by moving things around and distributing and using a little bit of algebra to rewrite the equation in a different order. So in slope-intercept form, you've got y equals mx plus b, where m and b are the bits of information that you need in order to write the equation in mx plus b. You leave the y and the x generic because they stand for every xy coordinate along the entire line, and so you leave those generic, or you leave those just simply x and y, and then you fill in a value for m and a value for b. So in order to write an equation in mx plus b, you need an m and you need a b. Right? And the name slope-intercept tells you need a slope and an intercept. Okay, so those are the two bits of information that you need in order to write an equation in slope-intercept. Standard form, the name doesn't really help us as far as knowing what is in it, but you still have that generic x and y. So you've got values for a, b, and c, and you have a generic x and y, again, that stand for every single xy coordinate along that entire line. And you typically, given a point, given 2 points, given a slope, given a y-intercept, you can't start in standard form, okay? You can only start in slope-intercept or point-slope form given some information, and then you've got to do the algebra to move things around to get into standard form. Unless they just give you the equation in standard form right off the bat, that's not a starting point for linear equations. So when you're given a point and a slope, or you're given a point or a slope and a y-intercept, or you're given 2 points, you're either going to start in slope-intercept or point-slope form. And then you're going to do the algebra. If you're asked to get to standard form, you're going to do the algebra needed to move things around to get to standard. So our last form that we've kind of hinted and talked about just a little bit over the last several days, but we're really going to dive into it a little bit more today, is point-slope form. And I really like point-slope form for the fact of when you're given a point and a slope, it's great. You can write it in point-slope form, right? So you can just you can just plug in the point and the slope, and then if you're asked to get it into slope-intercept or standard, you can just do a little bit of algebra, a little bit of moving things around, and you can get into any of the other two forms from point-slope form. And it saves you that step of having to find your B, which is what we did yesterday. And so we'll kind of get into that a little bit more. But let's look at point-slope form. So with point-slope form, right, you still have, this is the same thing that's on the other slide. Point-slope form, you still have the generic x and y. Okay, that black x and y, that's your generic x and y that in your final answer is going to stay generic x and y. You're not going to plug values in for that. The m is still your slope, right? The red m is still your slope, just like it is in slope-intercept form. The green x and y are that x1, y1. That's a given point, right? So that's if you're given information about a line and you're given a point and you're given a slope, rather than having to find your b and then write it in slope-intercept form and then go to standard form or whatever, if you're given a point and a slope, you can just write it directly into this equation and start from there. So just as kind of a recap, right, our m is our slope, okay, and our x and y, or I'm sorry, our x1, y1, the green x1, y1, that is a given point, okay, a given point. And then, like I said, the black x and y, that just stays generic, okay, it stays x and y, and it stands for every x and y coordinate along the whole line, okay? All right, so let's do an example, and I think as we walk through these a little bit more and I show you kind of what you can do with point slope form, it'll become a little bit more clear. So let's say we're given the point 1, 2, and we're given the slope is 2. Okay, so we're given a point, we're given a slope. Makes it pretty easy to write it in point slope form, because point slope form, you need a point and a slope. Okay, so this is our x1 and our y1, and this is our slope, right? This is our m. So if we write, let's just say that we're asked in the directions to write an equation in point slope form, right? That's our directions. Well, if we're asked to write it in point slope form and we're given a point and slope, you can't ask for anything much easier than that, okay? So we've got our generic y minus our given y of 2, right? So it's generic y minus y1 equals our m, okay, which is our slope, and in this case, our m is 2. That's our given information. Bracket, generic x minus our x1, or our given x, which in this case is a 1. Now, of course, you don't have to use all the colors when you do this, but I'm just showing you where I'm getting all the information from. So if you're asked to write it in point slope form, you're done. It's in point slope form. Okay, that's the answer. Now, what if you're given a point and a slope and you're asked to write it in slope-intercept form, right? And we know that that is y equals mx plus b. Well, you've got options here, okay? You can use what we learned today, which is if you're given a point and you're given a slope, start there. Start in point slope form. Plug it in to the formula, and then instead of stopping for point slope form, you would do a little bit of algebra, a little bit of moving, and get it in slope-intercept form. So, and we know to start manipulating and moving things around, the first thing we do is we distribute. And so when we distribute, we get y minus 2 equals, well, 2 times x is just 2x, and 2 times negative 1 is negative 2. And then we still want to get it in y equals mx plus b, so we got to move that negative 2. So we add 2, and we add 2, and we get y equals 2x plus 0. And that's okay to have a 0 for the b, right? So if I were to ask you, what is the b here? Well, the b is 0, or the y-intercept is 0, okay? And, right, if you were asked to write it in slope-intercept form, this would be your answer, okay? And so if you're given a point and a slope, and you want to start in point slope form, great. If the directions say end in point slope form, then you're done. If the directions say write it in slope-intercept form, you can do a little bit of algebra and you can get to slope-intercept form. And then what if the directions say to get it in standard form? Right? What if the directions say standard form? Well, we had y equals 2x plus 0, right? That's where we got to. Well, we know we can do a little bit more moving and get into standard form as well. So we subtract the 2x, and we subtract the 2x, and we get negative 2x plus y equals 0. And we know we can't leave that negative out there in standard form. So I divide by negative 1, divide by negative 1, divide by negative 1. That changes my negative 2x to a positive, my positive y to a negative. Now it doesn't change 0. You don't have a positive or a negative 0. 0 just stays 0. And this is standard form. All three of these forms are the exact same line. If I were to go to Desmos.com and I were to type in y minus 2 equals 2 times x minus 1, it's going to graph the line. If I type in y equals 2x plus 0, it's going to graph the exact same line. If I type in 2x minus y equals 0, it's going to graph the exact same line. These are all three the same line. They're just written in different forms. So when you're on this indicator, especially when you get to the review, when you're given instructions to write in whatever form, okay, that's your end point. That's probably not going to be your beginning point. So in this case, we were given a point and a slope, so we started in point slope form. If that's where you were asked to end, end it. If you were asked to get it in slope-intercept form, do a little maneuvering and then end it here, right? If you were asked to get it in standard form, do a little bit more maneuvering and end it here. Make sure your end is always what your instructions say to end with, okay? Now, I do want to go back here and just show you, based on yesterday and the day before we knew point slope form, if you were given, right, this information right here, if you were given a point and a slope, we could use this y equals mx plus b, and we could plug in what we know, right? We knew the y was a 2, one of the y's, that's just one of the many points, but we knew the y was a 2, we knew the m was 2, we knew the x was 1, and we didn't know b. And so 2 times 1 is 2 plus b, and then we would subtract 2 and subtract 2, and we would get that b equals, well, 2 minus 2 is 0. And so with the information of our given point of m equals 2, and now finding out that b equals 0, we could write y equals 2x plus 0. And again, you'll notice, right, this and this one are identical. Okay, they're the exact same thing. You can do it either way. If you're more comfortable using mx plus b, finding your b, and then with your m and your b, writing your equation in slope-intercept, that's fine. If you get comfortable with point slope form and you want to start there and then maneuver to whatever the directions say to get to, you can do that as well. Okay? All right, so let's look at another example. This will be example number 2. And for example number 2, we are given the point -3, -6, and we're given the slope is 1/2. And our directions just simply say write in point slope form. Okay? So we're asked to write it in point slope form. We're given a point, we're given a slope. These are the easiest ones to do, okay? Because you're given the information that you need. So point slope is generic y minus, okay, right? This is x1, y1 here. Remember that. Okay, so it's y minus y1. Well, it's y minus a -6. You got to really watch your signs here, right? Because the equation says y minus. Then if your y1 is also minus, you got to account for that as well. So y minus a -6 equals your m, which is your slope, and then x minus a -3. So again, you got to watch your signs. Now let's clean this up a little bit because we're in point slope form, but we're in messy point slope form, and we don't like to leave double signs. So we're just going to clean this up a little bit. Y minus a minus is plus 1/2. X minus a -3 is +3. And that is your equation in point slope form. That's what you were asked. That's what you did. And there's your answer. Okay? All right. Let's do one more example of the easy one, just because it's kind of quick and easy. So we've got -3, 0, and we've got m equals -1. And you're asked to write it in point slope form. Okay? So we've got y minus our y, and this is our y1 here. So we've got y minus 0 equals our slope, which is -1, x minus a -3, right? Don't lose that. X minus a -3, because this is our x value. And now again, I'm going to clean this up a little bit. So this can really be cleaned up kind of a lot. You can keep this 0 here, or you can not write it. It doesn't matter, because y minus 0 is just y. So you can actually write it with or without the 0. The -1, you can write the 1 or not. It doesn't matter, right? So you can just put a negative sign here, or you can do a -1. And then x minus a -3 is +3. Okay? This would be correct if you left the y minus 0 and you left the 1. That would be fine as well. That would also be correct. Okay? This is point slope form. Now, what if you were asked to get it in slope-intercept? Okay, what if you were given a point and a slope, so you started in point-slope form, but what if the directions say slope-intercept? Well, we can go from this point right here, and all we have to do is distribute that negative. Okay, that's it. That's the only thing you have to do to get it in point-slope form. Distribute that negative, and you get y equals negative x minus 3, and now we're in slope-intercept form. Okay, what if we were asked to get it to standard form? Well, all we would have to do is add an x and add an x, and for standard, right, we would have x plus y equals negative 3, and that would be our standard form. So with a point and a slope, you can write it in point-slope form, you can write it in slope-intercept form, or you can write it in standard form. Okay, all depends on what the directions say to do, and use a little bit of algebra to get there. Okay? All right. Let's see. We've got just 2 more examples here. So in example number 4, we're given 5, 4, and we're given negative 1, negative 3. And we're asked to write it in point-slope form. Now, obviously, if we want to write it in point-slope form, we need a slope, right? Can't do anything with linear equations without a slope. So the first thing we're going to do is go back to last Wednesday and finding slope, and we're going to find our slope. And this is x1, y1, x2, y2. Hopefully you're very familiar with this. We've been doing this for a week now with the slope. Now let's plug in. y2 is negative 3 minus y1, which is 4, over x2 is negative 1 minus 5. Negative 3 minus 7 is negative 7. Negative 1 minus 5 is negative 6. Clean that up a little bit and we get 7 6. So we know our m equals 7 6. Now, if our directions say point-slope form, does it matter which point we use? Absolutely not. Okay? If it were me, I'd hit the easy button and I would use x1, y1 because there's no negatives to mess with. And so if I used x1, y1, my point-slope equation would be y minus my y1, which is 4, equals my slope, which is 7 6, x minus my x1. I don't even have to clean anything up. That is point-slope form. Now, could you use the other one? Absolutely. Could you use x2, y2? Sure. So the other possible answer is y minus a minus 3 goes plus. Okay, I'm going to clean it in one step. So y minus a minus goes plus. My slope is 7 6. And then x minus a minus 1, because my x2 up here is minus 1. Right now I'm using this point right here, okay? So x minus a minus 1 is plus 1. Is that also point-slope form? It is. Both of these are correct, okay? If you're given 2 points and you have a slope, then you can either write it given point 1 or given point 2. Both of these are correct answers, okay? All right, let's do one more example. And then I want to kind of talk about your homework just a little bit since you're not in class to have me help you. All right, so we're given the point 0, 3, and we're given the point 5, 5. And we're asked to write it in point slope. Well, we know we need a slope. Can't do anything without a slope, so we're going to find that first. So we've got x1, y1, x2, y2, right? Finding my slope, I've got y2, which is 5, minus y1, which is 3. And then I've got x2, which is 5, minus 0, that's my x1. So 5 minus 3 is 2. 5 minus 0 is 5. So I know my m equals 2/5. So I know my slope. And I want to write it in point slope form. So I'm going to use this point, okay? And I'm going to write it in point slope form. So I've got generic y minus my y1, which is 3, equals my slope, which I found to be 2/5, and then x minus my x value, which is 0. Okay, there you go. If you wanted to write it using the other point, let's do that in a different color here. If we want to use this point, okay, we would write it as y minus my y2, which is 5, equals my slope, x minus my x here, which is 5. Okay, and that's point slope form. Now, what if I was asked to write this in slope intercept? Okay, a couple of different ways you can do this. One is you have a slope, you need a b, right? You can either find the b the way we did yesterday, or you can recognize that they gave you the b because when x is 0, the y is your y-intercept, right? So we could actually write this right off the bat without any more math. Y equals 2/5 x plus 3. Okay, we got that from the slope we found, and we noticed that they gave us the y-intercept. But what if you don't notice that? Well, come back over here to this one, and let's use a little bit of algebra to put this in slope-intercept form. So we've got y minus 3 equals 2/5 times x is just 2/5 x. 2/5 times 0 is just 0. Anything times 0 is 0. And then in order to get the y by itself, we add 3 and we add 3. And should be no shock, we get y equals 2/5 x plus 3, which is exactly what we got over here. Okay. And if we used this one, I'm going to go over to a new screen here. So we got y minus 5 equals 2/5 x minus 5, right? That was what it was when we used the other point. Yeah. So what if we wanted to use this point to get it in y equals mx plus b? Well, same thing. We're still going to distribute, right? And we get y minus 5 equals 2/5 x. We already knew that. And then come out to the side. 2/5 times negative 5 over 1. Cancels, cancels, and you get negative 2. And then we add 3. Oops, add 3. I'm already given my answer here. We add 5. Sorry about that. Add 5 and add 5. And we get y equals 2/5 x plus 3. We got the exact same answer. Y equals 2/5 x plus 3. Y equals 2/5 x plus 3. Y equals 2/5 x plus 3 over here. We got the exact same answer no matter how we worked it. The reason is because given this information, these 2 points, finding the slope, it's all the same line. So no matter how we maneuver it, how we work it, how we write it, which point we use, if you find the b first and write it that way, if you use your point slope form and you get into different forms using different points, it's fine. If you were just asked point slope form, either this one or this one would be your stopping point. And either one would be the right answer. Okay, because that comes from that point, that comes from that point. If you're asked to get it in slope-intercept form, do a little bit more work to get to slope-intercept form, okay, or find your b, which it was given, or do the algebra to get the other one to slope-intercept form. And then last but not least on this one, what if we're asked to get it to standard? Okay, well, we know to get it to standard, we multiply by that denominator, which is 5. And so we have 5y equals, the 5 cancels out, we're left with 2x, and then 5 times 3 is 15. Subtract the 2x, subtract the 2x, and we get negative 2x plus 5y equals 15. Divide off that negative like we know we need to do, and we get positive 2x minus 5y equals negative 15. So again, right? Whoops. This is standard. So same line. It's either in point-slope form, which is here, slope-intercept form, which is here. You can get that a couple of different ways, or standard form, which is here, just by a little bit of moving once you find your x. All right, one thing I want to cover on your homework. Let me get a copy of your actual homework from today. On your homework, the first 4 ask you to write it in point-slope form, and they give you a point and a slope. So those are like our first couple examples. Pretty easy, straightforward, okay? The next 4 are still asking you to write it in point-slope form, but you're given 2 points. So you have to find your own slope, use either one of the 2 points, and write your equation in point-slope form and leave it at point-slope form. For number 9 and 10, read your directions really closely, and I added a couple hints to those directions. But for 9 and 10, it says write the slope-intercept form, okay? Slope-intercept form. So you have a couple of options. You can start in point-slope form and then distribute and move things around and get y by itself. Or you can do what we did yesterday, which is find your b, and then use your m and your b to write it in slope-intercept form. Either one works, okay? For numbers 11 and 12, you're asked to write the standard form. And so you're given a point and a slope. You have a couple of options. You can use point-slope form, distribute, move things around, get it in standard, or you can find your b, write it in y equals mx plus b, and then move things around and get it into standard form. But this is going to give you a little taste of your review, which is every section you've got to really watch your directions carefully. Circle, notate, highlight, whatever you got to do to remind yourself what your end form has to be, okay? If your end form is point slope, plug in the point and the slope, leave it. If your end form is slope intercept, find your B or plug into slope in or point slope, move things around and get it in slope intercept form. And then 11 and 12, start however you want, either yesterday's or today's method, and then do some distribution and some moving around and get it in standard, okay? If you have any questions, I'm here all day. Email me. We can do a video, Google Video Meets call if you need more help than just a quick email, or you can just take a picture or a screenshot of the problem you're working on, shoot me an email and say I'm stuck, and I'll give you a bump on the next couple of steps, and hopefully that helps you get to where you're going. All right, let me know if you need anything, and I will see in-class students tomorrow, and I will put another video up tomorrow for my virtual students for the review. And let me know if you have any questions.